Today we will solve another LeetCode problem that is asked in some of the top companies like Facebook and Google, and it's problem number 91, and it's called Decode Ways. And this problem says that we have a message and it contains letters from A to Z, and these are all capital letters, and these are represented as numbers. So for example, if we want to send A, I will put 1 here. Similarly, 2 for B, and so on till 26. And we have to find how many ways we can decode a given string which contains these numbers from 1 to 26. For example, if the input is 12, it can have two ways of decoding. One is that this 1 denotes A and this 2 denotes B. So one possibility is that this message is AB. But other possibility is that 12 is also a valid code for L. So it can be also just one letter L. So there are two ways we can decode it. It's not like Huffman encoding where there's a unique decoding. It's a simple encoding, and here there are multiple ways of decoding the same message. And this is a very simple example of that. Similarly, you can see this one. So first understand how we will approach the problem. So if we have an empty message, we can say that there is no decoding of this, or we can also have one decoding of that. Whatever you want to take as base case, that will depend on what LeetCode says. We will keep it aside and we will, let's assume that it's 1. And now let's say we have approached somewhere here at ith position in the encoded message. So for encoding this, if we know how many ways we can decode this part of the message before ith letter, then we can also find in how many ways we can decode from 0 till ith position. So this is a simple dynamic programming problem. So if you remember Fibonacci, so here what this will depend, let's see. So let's say we know the answer till this part, that with so many digits, I minus 1 digits, there are n of I minus 1 ways to decode the message. Now, how can we find till this point? We will just add one letter at a time and we will reach till end. So we are right now looking at this ith position. So there are two possibilities. This ith letter can independently be represented, independently be decoded, because we can have values from 1 to 26. So here 1 denotes A, 2 denotes B, and so on till 9 denotes possibly I. So if this digit will be anywhere from 1 to 9, then it has its own decoding from A to I. So that is one possibility. The other possibility is that what was here. So if some letter here was less than equal to 2, if it's more than 2, then definitely we cannot add to it like 3 and this current digit, let's say 4. Then 34 is not valid. So this only possibility will be there. But if it's less than, combined value of these two digits is less than or equal to 26, then we can also represent it as one code where 26 will mean Z. Similarly, if this 2 digit is 19, then we can have some letter from A to Z. So two cases arise. So if we know the value of n of I minus 2 and n of I minus 1, then we can calculate the value of n of I. Why? Because if this I, the ith letter, is any value between 1 and 9, then we will simply add this, because we will represent all the numbers from 0 to I minus 1, and this is independently valid. So this number of ways, and additionally we will check that the combined value of these two digits, for example it may be more than 26 or less than equal to 26, is valid. Then we will represent this part, number of ways we can represent till this part, and then this 2-digit number. So we can add this one, but based on some condition. So let's start writing the code. So first the base case, if s dot length is less than 1, then we can return 1, or we can return 0. I don't know what is the test case for this in LeetCode. And if it's less than 1, that is its empty string, simply return 0. If the first letter, so if it's not an empty string, then it will have some first letter, so S0 is valid. And if it's equal to 0, character 0, then we cannot have a representation, because the values are from 1 to 26, and 0 can only occur as the second digit. For example, in 10 or 20, these are valid. But if it occurs in the beginning, this encoding is not valid. So we will return 0. And now if it's just a one length, this string has just one character, so we have already taken care of 0. So it can only be from 1 to 9, because a single digit can only take values from 0 to 9, and we have already taken care of 0. So it will be from 1 to 9. So if s dot length is equal to 1, then there is only one encoding possible. For if it's 1, it's A, if it's 2, it's B, and so on till I. If it's I, then if it's 9, then I. There is no other possibility. So now we have taken care of the base cases. Now we will come to this logic, that for determining the value of ith character, that is solution, number of ways to decode from 0 to I, will depend on the previous two solutions. So we always need to keep track of two values. We will call this val1 and we will call this val2. So we just need two variables. We don't need to store the entire solution from 0 onwards. We just need the previous two solutions so that we save some space. So we will define two variables, val1, and we will start iterating from character, second character of the string, because we have already taken care of first character and empty character. So here val1 will denote empty character. We can keep it 1, and val2 will also be 1, which is one character. Now we are ready to iterate through the entire string, the encoded string. So I will not start from 0 but 1, and I is less than s dot length plus I. Now first digit, we will call it D1. That is the current digit, which is s of I minus this value of 0, the ASCII value of 0. So this will give the exact integer value from 0 to 9. And let's D2 denotes this part, this combined value of the current digit and the previous digit. In this case, for example, 34, 26. So how we can calculate that? We will write I minus 1, that is previous character. To get the integral value, subtract the ASCII value of 0, then multiply by 10 because it's in tens place, and plus the current digit, which is D1. Now we need to check if D1 is valid, that is it's more than 0. So if D1 is greater than equal to 1, for 0 this can only exist as second digit, not as independent digit. So if it's more than or equal to 1, then only we will add to current solution. So let's keep one current solution also. So val plus equal to val of 2. Because we had said that we will denote this I minus 1 solution till I minus 1 as val 2. So we will add val 2 here. And the other condition is that if D2 is also valid, that is it's greater than equal to 10 and D2 less than equal to 26, then we will add V1 or val1 to current solution. And now we need to update these val1 and val2. So we shift by one step right. So if we move here, then whatever was, so this was val2, this was val1. But if we move here, this goes away, this becomes V1, and the solution that we just calculated becomes V2. So we will accordingly update here. So val1 gets the value of val2 and val2 gets the value that we just calculated. And finally we will return val2 because val2 is the latest calculation. And let's run it. We will try some test cases on ourselves and then we will go ahead and submit the solution. So 1, 2 is valid. Let's change our test case. Let's say we have 1, 2, 3. It's valid. And we can add 1, 0. So here there is only one possibility because 0 cannot independently exist. 1 can exist, but if we make 1 as independent, then this 0 becomes invalid. So only possibility is 1, 0, which is J. So it should return 1. So you can try on a few more test cases that comes to your mind, and if you are satisfied with it, you can go ahead and submit it. So let's see if it passes all the test cases. So yes, it gives a runtime of 0 millisecond, which is faster than 100% of users. And also in terms of memory, it's better than 100%. That is, it's probably the best in terms of time and memory.